Hello everyone. So this video is going to go over annuities, and I think with annuities and then a section on mortgages, we should be wrapping up the topics on financial economics. So let's get started. Let me share my screen. So yes, as I mentioned, this video will go over what is called annuities. But before we do that, let me give you a quick primer on how to calculate the sum of geometric series, because we're going to use these formulae in annuities and mortgages. So a geometric series is one where every number is obtained by multiplying the previous number with a particular constant, with the same constant. So in this example, we have a series a plus ak squared and so on. So to get from a to ak, we multiply by k. From ak to ak squared, multiply by k. And we keep going on. And this is how a geometric series is defined. Now, of interest to us about geometric series is how to calculate the sum of a geometric series. So if we are given a finite geometric series, or one where there are a finite number of terms in the series, or let's say n terms, then the sum of that series, so we have a series here such as a plus ak squared and so on, up to ak to the power n minus 1, so that is essentially n terms. And the sum of that is given by this particular expression that you see here. Let me use a different color for that. Oops. Okay. So this expression gives us the sum of a finite geometric series, where a is the first term in the series and k is the factor by which you multiply each term to get the next term. And this expression is only valid when k is not equal to 1, because when k is 1, the denominator becomes 0, so the sum is indefinite. But I mean, this expression is indefinite. But to see what happens to the sum when k is equal to 1, I've written this scenario here. So read it, look through it and understand what's going on. So another expression to calculate the sum of finite geometric series, I mean, these are essentially, both the two purple boxes are essentially the same formula. It's just that in the second one, I've taken out the negative. I've written k power n minus 1 as minus of 1 minus k power n. K minus 1 written as minus of 1 minus k. So the negatives cancel out and you end up with the formula. But they're essentially the same thing. So you can just use whichever one works for you best in that scenario. Now, if we have an infinite geometric series where we have something like a plus ak squared and so on, but it keeps going on and on and on, there is no finite end in sight. So how do you calculate the sum of an infinite series? Well, we have a formula to calculate the sum in a specific case where the absolute value of k, or absolute value of the number by which you multiply to get the next number in the series, k needs to be, the absolute value of it has to be less than 1. In that case, the sum of an infinite geometric series is defined and given by the formula a by 1 minus k. Now, we later on, once when we learn about limits, when we do differential calculus, the same principle of limits has been applied to this scenario to arrive at this nice, concise formula to calculate the sum of an infinite geometric series. So a series, an infinite series, geometric series for which a finite sum exists is called a convergent series. Well, if the sum does not exist, it's called a divergent series. And the more advanced courses you do, either in math or economics, you will see, when you work with series and everything, you will hear about convergent and divergent series. And I thought it would just be nice to orient you or just introduce you to the vocabulary. So, but apart from that, the main points we need to carry away from this page are the formula to calculate the sum of geometric series, finite and infinite. All right. So I mentioned that the subject value of this video is going to be on annuities. But before that, a very quick recap of what present value is essentially doing. Now, if I have a dollars in the present, and I'm told that this amount is going to grow or compound at the rate of R% per period, and I end up with a final amount of k in the future. Now, how does this movement from a to k happen? Now, let's say we have n time periods over which this compounding happens. Then a grows by a factor of 1 plus r per period for n periods, and we get the total amount k. So this is how we move from the present to the future. Okay? So you start off with the number a, and then you move to k by multiplying or by compounding. So this is compounding. Now, if we want to move back from the present value to the future value, so suppose we are given k and r, then find a. Then you know that a times 1 plus r power n gives us k. Okay? Therefore, we can find a by saying that a is just k by 1 plus r power n, or k is k times 1 plus r power minus n gives me a. Now, a is called the present value, and k is the future value. And this act where you divide by 1 plus r power n is called discounting. And this is a recap from what we did in the lecture. Now, we know how to calculate present and future values. One scenario that we saw in last lecture was how to calculate the total present value. So the scenario where we have to do this is often of the type where we have to make n successive payments. And these are to be made, just give me 1 second here. Yeah, so we have to make n successive payments, A1 to AN, where A1 is paid after year 1, A2 after year 2, and so on to AN. Now, how much money should we have today to be able to make all of those payments at the specified time? To be able to pay A1 after year 1, I should have A1 by 1 plus R today. To be able to pay A2 in 2 years, I should have A2 by 1 plus R the whole square today, and so on, and we keep going up to n. And when you sum up the value of all of those payments, that all of those amounts, that is the total amount that I should have today in order to be able to make those payments in the future. And that's the present value of the money you need to be able to pay A1 in year 1, A2 in year 2, and so on up to A. Now, this is the foundational principle behind studying annuities. What are annuities? An annuity is a sequence of equal payments that are made at fixed periods of time over a given time span. Now, let's look at an example, and that should start making the idea of annuity more easier to follow and understand. So, how much do you need to invest now at 4.8% per annum if you want to provide regular payments of 500 per year for the next 5 years? Let's understand this question. So the question is asking us how much money we need to invest or save now in order to be able to provide a regular payment of $500 per year for the next 4 years. Meaning that from now, in 1 year from now, I have to pay 500. 2 years from now, another 500. 3 years from now, another 500. 4 years from now, another 500. To be able to pay all of these amounts in the future, how much money should I have right now so that I'm able to make all of these payments in the future? So the key word now is one indication for you to tell that they're asking us to find the present value of something. Let's go ahead and find the present value. And I'm just using the same principles that we saw in the total present value example, except that now the amounts are all just the same. Instead of A1, A2, A3, AN, I just have one A. Okay, so to be able to pay 500 in 1 year from now, the present value of that 500 1 year from now is just given by 500 by 1.048, or this is nothing just but 500 by 1 plus 0.048, because R is 4.8%. Now, let's do this for the second year as well. To have $500 2 years from now, today I need 500 by 1.048 square. Similarly, if I need 500 3 years from now, if I need to make that payment 3 years from now, today I should have 500 by 0.048 cube. And then finally, for the last year, I should have 500 by 1.048 to the power 4. Now, if I sum up all of these 4 present values, the sum of that is going to be the entire amount that I need today to be able to make the payment as specified at each time point for the next 4 years. Now, how do I calculate the sum? Well, I've given you the sum of this is a finite geometric series with A given by 500 by 1.048, K defined this way, and N is equal to 4. Plug these numbers into the formula to calculate the sum of a finite geometric series, and you should end up with something that looks like this. Now, let's generalize this. And this is an example of an annuity because you're making the same payment every time period. Now, instead of $500, let's say we have to pay $8 per period for n periods at the rate of interest per at our rate of interest per period, and each payment is now made at the end of the period. How do you find the present value of this annuity, of this sequence of equal payments? Well, if I want to have A at the end of year 1, I should invest, or I should save A by 1 plus R today. So this is all present value here. To have A in second period, I need to invest A by 1 plus R squared today. At the end of the third period, I will need to invest A by 1 plus R cubed today. The idea is that this amount will grow over 3 years, will compound over 3 years to give me A. So A by 1 plus R cubed will grow at a factor of 1 plus R cubed, which will then give me the answer A. So that's how we're moving between present and future values here. And if we keep going on, for the last period, N, I should invest about A by 1 plus R to the power N today. Now, the present value, the total present value of this annuity is given by this expression. A by 1 plus R by A by 1 plus R. Sorry, let me move these brackets. 1 plus R squared, and you keep going on until A by 1 plus R over N. Well, this is the total present value of the annuity. And we know that this is a geometric series. It is a finite one with A given by A by 1 plus R and K given by 1 by 1 plus R. And the total number of time periods is N. So if I want to calculate the sum of this series, I am going to do Sn is equal to, or the PV, total present value, is A by 1 plus R into 1 minus 1 by 1 plus R to the power N by 1 minus 1 by 1 plus R. If I expand and write this out, this is going to be 1 plus R over N minus 1 by 1 plus R over N divided by 1 plus R minus 1 by 1 plus R. If I expand and write this out, I have A by 1 plus R into 1 plus R over N minus 1 by 1 plus R over N into 1 plus R by R. Well, this 1 plus R will get cancelled with this 1 plus R, and I will end up having A by R into 1 minus 1 by 1 plus R. And this is the formula to calculate the present value of an annuity. I just wanted us to derive the formula so that it stays in our mind. It gives us a better intuition of how to get to the present value of an annuity. So I will stop this video here, and in the following video, I will continue and I will walk you through how to calculate the future value of an annuity. And then in a subsequent video, we'll apply these principles to understand mortgages. So I will see you in the next